Hello everyone, welcome. Today I want to talk about factoring using the AC method. So get yourself something to write with because writing and thinking should always go together. And let me share my screen with you. So factoring quadratics using the AC method, it's when your leading coefficient is not 1. But before we redo that, let's just review a bit. Go ahead and press pause in the video and multiply these two binomials that you see here. Multiply 2x minus 5 times x plus 3. Go ahead and pause the video and start back up when you're finished. Okay, are you done? Let's see if we get the same thing. So I'm going to be using the distributive property, and so a 2x times an x gives me a 2x squared. 2x times a 3 gives me a plus 6x. Negative 5 times x gives me a negative 5x, and then negative 5 times positive 3 gives me a negative 15. And now if I collect my like terms, I'm going to get a 2x squared plus x minus 15. Is that what you got? Good. Okay, so what does it mean then to factor? Remember that factor means reversing the multiplication process. So factoring would be, how do I take this thing that we've got, the product, how do I take that and go backwards to get 2x minus 5 times x plus 3? If factoring is reversing the multiplication process, what I want to know really is how do I find these two pieces right here, 6x and a minus 5. We combine them together to get a positive x. How do I take them and break them into two different parts? Because that will then allow me to factor it by grouping to get my original thing back. So recall that a quadratic in standard form looks like this: ax squared plus bx plus c, where a, b, and c are the coefficients on the x squared, or the x pieces, or the variables. So in the situation that we've got here, a is equal to a positive 2, b is equal to a positive 1, and c is equal to negative 15, right? Those are the coefficients on my variables or my constant term. So watch the method that I'm going to use here. And I recommend that you put your pencil down if you're taking notes and that you just watch and listen and then pause the video to get yourself caught back up when you need to. So let me start with the piece that we've got here. Let me start with 2x squared plus x minus 15. And now I'm going to obscure the original answer there. What I'm going to do is I'm going to take my a, my leading coefficient, and I'm going to multiply it by the c, my last piece that I've got here, the part with no x. So I'm going to take 2 times 15. Don't even worry about the negative sign. Just take 2 times 15. What does that give me? That gives me 30. Now I'm going to make a list over here on the side of all of my integer factors of 30, all of my whole number factors of 30, and I'm systematic with it. So I'm going to do 1 times 30. 2 works, 2 times 15, 3 works, 3 times 10, 4 does not work, I will leave that one off, and then 5 works, 5 times 6, and then after 5 comes 6, but I've already got it. So I'm finished with this now. This is my complete list of all the factor possibilities of 30. Now, here's what I'm going to do. I'm going to pick a pair. I'm going to pick a pair that when I subtract them, see that minus sign on the C term right there? That subtraction? Which ones, when I subtract them, give me the number that sits right here, the number 1? Is the difference between 1 and 30 1? No. Is the difference between 2 and 15 1? No, it would be 13. What's the difference between 3 and 10? That would be 7, so it's not that pair. Look, it's the 5 and the 6. The 5 and the 6, when I subtract them, give me the number 1 right here. So I'm going to take this middle term now and I'm going to split it into two different parts. I'm going to split it into a 5x part, and I'm going to split it into a 6x part. And again, I got those from the pair that I chose there, that subtract to give me 1. Now, how do I get a positive x from a 5x and a 6x? Now let me think about signs. In order to get a positive x, I'm going to have a positive 6 and a minus 5. So really, I've taken that middle term of x and I've broken it into two separate pieces, a negative 5x and a positive 6x. Now, I'm just going to carry down the pieces that I'd had before. The 2x squared comes down here, 2x squared, and the negative 15 carries along, negative 15. So instead of a 3-term quadratic, I've now got a 4-term because I split that middle term into two pieces. Now that I've got 4 terms, just factor by grouping. Right? How do you factor by grouping? Well, you kind of break it into two different parts, a left-hand side and a right-hand side. I do a little dashed line down the middle. Now I look at the left-hand side. What can I factor out of 2x squared minus 5x? I can factor an x out of that. And then what remains? What I've got is I'm going to have a 2x minus 5 for that group. Now over on the right-hand side, I should also get a 2x minus 5. It's got to be the same thing. Now, what can I factor out of a positive 6x that would leave me a 2x? Hopefully you see that that would be a positive 3. And then just let me double check. If I take this positive 3 and I multiply it into negative 5, do I get a negative 15? Yes, I do. Good. So now I'm almost finished. The common factor that they share is the 2x minus 5. So 2x minus 5 comes out, and once I strike those through, what piece remains? An x plus 3. There we go. I have factored it, and let me look, because I forgot. Is that what I started with at the very, very top? 2x minus 5 times x plus 3? Yes! See, when I was in school, I was taught to guess and check. Think of all the different ways you might factor that by, and then just start multiplying it out and see if you get what you started with. And that doesn't seem very thoughtful or very mathematical, guess and check. Maybe you could arrive accidentally at the answer that way. Maybe you won't. There's certain cases where you won't. And then you have to be able to conclude rightly. So the strategy here, the AC method, says when my leading coefficient is not 1, like it was right here, it's a 2, I'm going to take the 2 times the 15, the A times the C, make a list of the factors of the product of AC, and then think about which ones, when you do the operation of C, whether it be positive, or in this case over here it would be negative, whether you subtract them, gives you your middle term, and then break your middle term into those two pieces, right? Do you see that these pieces that I had down here, a negative 5x and a positive 6x, were the same pieces that I had here originally when I multiplied? See, it's just reversing the process of multiplication. Also notice here that they're in the opposite order that they are down below when I factored. Here it's a positive 6x and then a minus 5. Here it's a minus 5 and a negative 6x. That's another point. It doesn't matter which order you put those two pieces in. You could just as easily have done the 6x on the left and the 5x on the right-hand side. It doesn't matter. It'll sort out the same. Okay, you think you got it? Let's try one. Let's try 2x squared plus 13x plus 15. I'm picking ones that have the same A and the C. Press pause on the video. Give that one a try. See if you can get the same thing I did. Okay, go. All right, I'll talk you through it now. I don't have a greatest common factor. There's nothing that I can factor out of all of those terms. So I'm going to take the 2 times the 15, call that 30. Now what I'm looking for is I'm looking for factors of 30 that when I add them this time, see, you have to go by that operation that you see right there on the C term. When I add them, give me 13. Which factors of 30 that when I add them give me 13? You can make your list, but I hope you see that it's going to be a 3 times a 10. If I add 3 and 10, I get 13. So I'm going to break that middle piece out into a piece of a 3x and a piece of a 10x. So this positive 13 becomes a 3x and it becomes a 10x. And now the signs, I have to both have a positive sign on those in order to make a positive 13 if I were to recombine them. And now I copy down the first term, 2x squared, copy down the last term, plus 15. Now I've got 4 pieces, split it down the middle, factor by grouping. On the left-hand side, I can take out an x, which gives me a 2x plus 3. And in hope, I also have to get a 2x plus 3 on this side. What do I factor out of 10x to give myself 2x? A 5, and it's got to be a positive 5. Always have to put a sign there. And then my last step is just mentally double check. If I take a positive 5 times a positive 3, do I get a positive 15? Yes, I do. And so now my common factor is going to be a 2x plus 3. And once I strike that out, the pieces that remained, an x plus 5, here we go. How long did that take? Less than a minute. Certainly a better method than guess and check. I have a math teacher to thank for this, and not in high school. Don Nichols was a teacher that taught at the high school that I went to as a student, but I never had him. And years later, when I became a teacher, I wound up teaching with him at a different school, and I had my own kind of method for doing this. I was taught just to guess and check in school, which was terrible. I had developed a method that I thought was pretty good, and Mr. Nichols was watching me do it one day, and he goes, "Why don't you use the AC method?" And I said, "What's that?" And he showed me this method, and I thought, that's profound, that's brilliant. Forget this guess and check stuff. All right, now let's try one that might be a little more difficult. How about 6x squared minus 13x plus 6? Okay, try to factor that. Do I have a greatest common factor? No. So take the a times the c. What is 6 times 6? That would be 36. Let me find the factors of 36 that when I add them give me 13. Don't worry about the negative yet. When I add them, give me 13. What would that be? Hopefully you can see that it's going to be a 4 and a 9. 4 times 9 multiply together to give me 36, but add together to give me 13. So I take the 13x and I break it into two parts. I break it into a part that's a 4x and a part that's a 9x. Now, how do I get the signs right? What do the signs on 4x and 9x have to be to give me negative 13? Hopefully you see that they're both negative because they have to combine back up to give me negative 13. Then I copy down the 6x squared, and I copy down the plus 6, and now I split it down the middle and factor by grouping. So then we're going to have a greatest common factor here of a 2x, which leaves a 3x minus 2. And on the right-hand side, in hope, let me write down a 3x minus 2. And think, what do I factor out of a negative 9 to give myself a positive 3? Well, I would factor out a 3, but careful with the sign here. I need to factor out a negative. Think about that. Let me double check. If I take a negative 3 times a negative 2, does it not give me a positive 6 if I were to multiply it in? Yeah, it does. I'm happy now. So this becomes 3x minus 2 times 2x minus 3. That's so similar, it's almost confusing. But there we go. Again, how long did that take? A minute, 30 seconds? I don't know, you can go back and look at the timestamp if you want to. How about another one? You get good at these, you can do them fairly quickly. 2x squared minus x minus 15. That seems familiar to me. Did we do this one already? 2x squared minus x minus 15? Oh no, we did 2x squared plus x minus 15. I wonder how this one's different. All right, again, no greatest common factor. Let me do 2 times the 15, 30. Factors of 30 that when I subtract them give me 1. Again, we would say that that's 5 and 6. Split this middle term out. A negative x becomes a 5x and then a 6x. And it has to be a negative there and a positive there. And on the earlier one, it was different. So you've got to keep it straight with the signs. 2x squared there, negative 15 here. Split down the middle, factor by grouping. Factor out an x here, which gives me a 2x plus 5. And this here, 2x plus 5. What do I factor out of a negative 6 to give myself a positive 2? that would have to be a -3. And double check, is a -3 times a positive 2x negative 6x? It is. And is a -3 times a positive 5 negative 15? Yes, it is. There we go. This is almost too easy. Almost too easy. And if other students hear you say, oh, factoring when the leading coefficient is not 1 is too easy, they may throw stones at you. Because if they were only taught to guess and check, this is one of the more anxiety-producing exercises in all of algebra. In fact, I remember being in high school, not with Mr. Nichols, but factoring, and it was just guess and check. And so I was doing a problem like this, and tried so many different variations, and none of them were working. I literally erased a hole in my paper. You ever been so frustrated at math and so unsuccessful at math and made so many mistakes in math that you erased a hole in your paper, like physically, like wore the paper through? I did. This is so much better than that. Maybe you can tell that I'm still happy about learning this method. This is great. Well, let's try this one. Let's try 2x squared plus 5x minus 6. Factor that one. Press pause on the video. Go ahead and try it yourself. See what you get. Yeah. Are you back? How'd it go? Well, let's see if you have the same process I do. So I'm going to take, there's no common factor. I'm going to take 2 times 6, that's 12. And factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which pairs of factors, when I subtract them, give me 5? Well, 1 and 12 doesn't work because the difference there gives me 11. 2 and 6 doesn't work, the difference there is 4. 3 and 4 doesn't work, the difference there is 1. Which pair of factors, when I subtract them, give me 5? There aren't any. What's your conclusion? Prime. Remember, a prime number is a number that cannot be factored besides itself and 1? Yeah, sometimes you can't factor. This one cannot be factored because there's no factors of 12 that when I subtract them give me 5. There we go. See, this was the one that I erased the hole in my paper on. I tried all the different possibilities. Maybe it wasn't this exact one, but it was one that was like this. Tried all these different possibilities and got lost as to which ones I had tried, which ones I hadn't tried, and like maybe did like one of the options 2 or 3 times or so forth, and nothing was working. Erased a hole in my paper. Went to class the next day. Mr. Lincoln, like I can't get this one to factor. Oh, it's prime. That can't be factored. What? How long did that take us to figure out that it was prime? Well, maybe not you, but how about me? How long did it take me now to figure out it was prime? 30 seconds? Yeah? See, this is a powerful method. And again, all we're doing is we're just working the multiplication process backwards. If you do it thoughtfully, it's fairly straightforward. Okay, last one. Let's do 3x squared plus 15x minus 18 factor. If you're multiplying 3 by 18, it's easier than that. All through these, I should have been if I wasn't, but I think I was. I was saying, is there a greatest common factor? And this one there is, right? I can factor the 3 out. Factor the 3 out of everything. That gives me an x squared plus 5x minus 6. Now all I have to do is factor the inside part, which doesn't require that I use the AC method because the leading coefficient there on x squared is just 1. So you should always check and see if you have a greatest common factor first. It will make the numbers easier. Now, you didn't have to. You could have multiplied 3 by 18 and done the AC method like we've been showing here. But then you would have had a term that had an extra 3 as a factor, and then you could have factored that one out. But this one just makes the number rather easy. But be careful with this one, though. This one that remains is perhaps a little bit tricky. What are my factors of 6 now, since my leading coefficient is just 1? Now, well, I'll come back to that in a second. What are my factors of 6 that when I combine them give me 5? 1 and 6 and 2 and 3. Careful here, both of them do, depending upon which operation. 1 and 6 combine to give you 5, but also 2 and 3 combine to give you 5. Depends upon whether you're adding or subtracting. Which one do I need to do here? I need to subtract. Which pairs of 6, when I subtract them, give me 5? It would be the 1 and the 6. So this one, I carry the 3 down. Always carry the greatest common factor down. It's like your luggage. You can't leave it. Then this is going to be x in the first position, x in the first position there, a 1 and a 6. How do we get a positive 5? That would be a positive 6 and a negative 1. There we go. That was from the previous lesson. You could do factor by the AC method here with this one. You could take the 1 times the 6 and you could take that 5x and split it out, because here's the deal. The AC method works with all of these. There are special factoring products like a difference of squares or a perfect square trinomial, special factor patterns that you can use. But the AC method will work for those too. The AC method will actually work with any quadratic if it factors. Anyway, that I think is one of the better lessons I could give in algebra. I still remember being stressed and anxious and all this guess and check and oh my goodness, this is impossible. I don't see how I can be expected to do all this. Well, let's not waste time. Let's be thoughtful about it. Let's just reverse the multiplication process. Thanks again, Mr. Nichols. It was a worthy method. May your day be merry and bright, and may all of your mathematics be right.